Ladies and gentlemen, as we approach Thanksgiving, maybe some of you are considering taking a hot air balloon ride. Maybe not. It's getting a little cool out there. What do we have here? We have, before we launch our balloon, typical pressure, a little less than 1 atm. So we'd say this is a low barometric pressure day. And it's a fall day at 14.42 degrees. That's not bad. It's not too warm, not too cold. That is close to 2.8 billion liters. Billion. That's a typical balloon. They're very big. Once you go up in the air, does it make sense that the pressure goes down? I hope so. Yeah. Gravity's acting on air. It acts more strongly where the air is close to the ground and less strongly up high. Similarly, if you go up in the mountains, the pressure goes down. Sometimes you feel a little lightheaded, have a little trouble breathing. Gives the Broncos an unfair home field advantage, but that's another story. We want to know if this balloon is going to shrink or grow, and it's not an easy question. Because when the pressure goes down, what's going to happen to the volume? And if you're having trouble remembering things like that, I'm going to get my pen first. Or maybe I'm not. I think my pen may have disappeared, everybody. Sorry. Yeah, sad times. We're gonna go and write on the screen with my hand. Good luck. Okay, so this is the first pressure right here. P1. This is P2. Remember, the pressure when multiplied by the volume and divided by the temperature under one set of conditions equals the pressure times the volume over the temperature under a different set of conditions. Make sure you get the activity back there. So we got P1 and P2. We got T1. We got T2. And we've got V1. And we don't have V2. That's our variable. Right there. We need V2 by itself. Maybe you want to start there. So we've got our equation here. And I'm going to manipulate it to get V2 by itself. Well, if I multiply this side by T2, then T2 disappears. Got an activity for you back there. So I'm going to multiply both sides by T2. You can do the same thing to both sides of an equation. If I divide this side by P2, P is in Paul, then it disappears. I'm allowed to divide both sides by P2. So what I'm going to do is multiply both sides by T2 and divide both sides by V2. I'm going to do that over here too. I know it's going to look a little messy, but we can handle it. T2 over V2. As long as you do the same thing to both sides. What's left over? Well, I'll tell you what's not left over. V2 from the right side is gone. T2 from the right side is gone. Reorganizing to get, I want P2 by itself? No, I want V2 by itself. Yeah. So I didn't want to get rid of V2. What did I want to get rid of? What did I want to get rid of? Help me out, people. What do I want by itself? V2. Don't cancel V2 over here, please. Cancel P2 over here. So I'm multiplying both sides by T2 over P2 over P2. So if we check our work as we go, we can catch mistakes. P2 gone. T2 gone. We're left with V2. I am just organizing my equation. V2 equals T2 over P2 times P1 V1 over T1. So are we ready to just plug and play, as I say? When you have all the numbers you need for an equation, we call that plug and play. But you are not ready to plug and play, because if you did plug and play right now, you would be getting a negative answer for the volume. And good luck interpreting what that means. We are living in a negative volume space here. No, we don't. Black matter, more than 80% of our universe, it's becoming clear. We don't know what it is. But it's more than 80% of the mass out there is probably stuff we don't understand yet. This was an interesting point that just came up. Okay. Then it might be involved in like a universe with negative volume. I don't think so, but we'll see. V2, okay. We can't have a negative temperature because there's no such thing as negative pressure or negative volume. So in every gas problem, what do you do with temperature that's not in degrees Kelvin? Yeah, make it into degrees Kelvin. So we got our Kelvin equation here. Degrees Celsius plus 273. I'm just going to do it right on the question. And you guys are going to work it out for me. I'm trying to get a plus sign in there. No pen today. And for T1, we'll put it in, whoa, we won't do that. Equals in red. T1 equals 287.42. I hope I have some calculator people here. It's a light attendance day with Thanksgiving today. Tomorrow. 287.42. Did I do that math right? Kelvin. T2. 273 minus 18. Well, I got a 3 minus an 8 is a 5. Yeah, I don't know. I want you to do it for me. That's what I want to hear. 254.68. Now we can plug and play, can't we? T2 was 254.68. Wow. I'm learning how to use my finger. Cannot touch the screen with any other part of my hand, apparently. P2 is 473.94. 4. Units, very important, right? Times P1, oh, I need all my numbers. P1 was 715.4 torr. How we doing here? 4 torr. Over V1, sorry, V1 was 2.791 times 10 to the 9th. It is having trouble keeping up here. And that was liters. T1 V1 over T1, correct? T1, 287.42. 287.42. Ladies and gentlemen, do not forget test 1. When doing this math, you should put these like that. Do the whole numerator first, then divide by parentheses, and give me the final answer. We can't see all the numbers though. There we go. Yeah, write bigger with my finger and learning that. So I'm just gonna wait it out. I might go to pause. Pause share. Is that a thing I can do? Let's try. Screen sharing is possible. I think we're still on video. So stop share. And, all right, ladies and gentlemen, we have an answer. If I can remember where we were. ChemDraw, no, Starboard. And the answer, whoa, okay, in black, why not? 37312730002. Did I get all those? 20 at the end?
No, 0.2.
05. 052? 002. 2 zeros is what you said. Thank you. And I'm not even going to trust myself with units. I know what we're asking for, but I'm going to check and see the units I've got. And did I copy something else, Ron? 27. Yeah. Thank you for that. 27 coming up. 273 and 07? 3002? There's a lot of numbers. That was on me, not you. Checking units. Kelvin, gone. Torr, gone. Liters, left. Hey, liters is a volume, right? That's how big something is. So I think it expanded a little, didn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 sig figs, is that what we were shooting for, or 3 sig figs? I can't even remember my question here. I got everything in 4 sig figs, don't I? It's my favorite go-to. 3.731 times 10 to the 9th. So our balloon expanded. Yeah. Which means the volume increased. Which of the two variables caused a volume increase? Which of this? Yeah, which of these two variables? There are 3 variables. Was it the temperature going down by more than 30 degrees Kelvin or Celsius, which is 30 degrees difference Kelvin? Here's how I like to look at things in percentages. Temperatures are here. Look how close those numbers are to each other. Okay? Torrs. This number is only a little more than half of this number now. That's a bigger change, right? Think about it. The ratio of the torrs together is like 1.5. And this thing is not 1.5 times this thing. No way, not even close. It's only like, or it only changed by 30 degrees Kelvin. That's like 10% difference out of 300 Kelvin. They're ballparking 300 Kelvin, right? Activity. Okay. So yeah, the pressure change dwarfed or made look small the volume temperature change. Sorry. That's why we went up. Anyway, that's a lot of talk. We just need to make sure we got all of this stuff on our activity before we give it away. Right there. And I got activity 2 for you.